एवरीवन, हाउ आर यू? कैसे हैं आप लोग? बेनाली, श्री गुरु, राइट, मोनिशा, एवरीवन, welcome to the session guys. Shiva, welcome to the session, and today we are going to discuss the communication part 2. And in the communication part 2, mainly we are going to discuss about the digital communication. So everyone, once confirm everything is fine, audio and video, so that we can start the session. Shubham, a very good morning everyone. And please inform to all of your friends so that more and more people will join the session and get benefited, because we are not going to start the session until the 50 people come live. So everyone, please inform to all of your friends so that more and more people will join the session and get benefited. Everyone, happy Makar Sankranti. Shubham, Nikhil, Amritanshu, Akash, everyone. Okay. Why only very less people are attending the session, guys? ऐसे मजा नहीं आएगा. Already I have given that कि at least 50 people should be live, then only we'll start the session, right? And what portion we are going to cover in this today's class, guys? Try to understand. First, I will give you the idea about because in the last class in the analog communication I have not discussed about the noise. So now I will give you the formula regarding to the noise of the analog communication in the AM, conventional AM, in the DSVSC, in the SSVSC, FM and PM. These five modulation scheme formula, signal to noise ratio or figure of merit formula I will provide you. And then directly we'll come into the digital communication. We are going to start with the PCM, pulse code modulation. Then we'll start delta modulation, DPCM, differential pulse code modulation. After that we'll start band pass modulation, that is called ASK, PSK, FSK, how we are going to find out the bandwidth of those scheme, how we are going to find out the modulation, or how we are going to find out just after that we are going to discuss M-array signaling also for the, especially for the PSK, what should be the Euclidean distance. This part we are going to cover, and just after that we are going to discuss about information theory. So this portion we are going to cover in the today's session, but we'll start the session only when up to 50 people are basically coming live. Otherwise we are not going to start, right? And one thing more, one announcement also, guys. Your admit card is going to be updated maybe in the today or tomorrow. आज या कल के अंदर, 2 दिन के अंदर आपके एडमिट कार्ड जो है वो अपलोड हो जाएंगे IIT खड़गपुर के वेबसाइट के ऊपर. Admit card in the sense, the information, whether the exam is going to be postponed, everything you will get the clarity today or tomorrow, right? Most probably today in the today evening. और मकर संक्रांति तो हो सकता है tomorrow भी हो जाए. Digital communication, more weightage topic. Kagula, if you want to discuss about the more weightage topic for the digital electronics, digital communication, I will discuss those points also before going to start. एक बार कोई इंपॉर्टेंट टॉपिक पूछा, बट आई विल नॉट स्टार्ट द टॉपिक अंटिल द 50 पीपल विल लाइव. दैट इज द श्योर शॉट, राइट? आई डोंट नो, बिकॉज we are taking the marathon session for the long marathon session for the 2 hours and 2.5 hours, and only the 20 or 30 people are coming live now. It's not practically, we can say that it's not good thing, right? Okay, देखो, first let me discuss about the important topic for the digital communication. तब तक मैं खाली important topic दे देता हूं. Now you can share among all of your friends. Digital communication. In the digital communication, the important topic is, everyone, in the digital communication, the important topic is the first one, right? And एक चीज और बता देता हूं, when this session is not going to be happen now, right, then I will never take the communication in this particular channel. That is the also short, right? Good morning Ankit, Chini, Kit Visualization, Akash, Shiva, बहुत ही बढ़िया. In the digital communication, guys, the 100% sure we can expect the one question from the PCM. 100% we can expect the question from the PCM, guys. Pulse code modulation. In the delta modulation, second, if you want to discuss into the delta modulation, only regarding to the slope overload distortion, SOD, regarding to the problem we can expect into the delta modulator, right? Okay. So this part is only 2 top question from the PCM either or from the delta modulation. Only these 2 topics we can expect the question. Then in the M array, most important topic is PSK, phase shift keying. Most important topic is nothing, it is just a PSK, pulse code, we can say that phase shift keying. In the phase shift keying, two type of question we can check, that bandwidth, probability of error, and mainly the constellation diagram regarding the problem. Constellation diagram regarding the problem we can expect, right? Okay. In the M array signaling. Just after that, guys, in the PSK, sometime ASK, but very rare. Most important thing is the PSK. And even if they are asking the question into the ASK, mainly they will ask the question into the ASK regarding to binary only, not into the M array, only into the binary. But in the PSK, M array is very, very important, guys, right? Now, if you want to discuss this one, we have already covered, right? Okay, M array signaling. M array signaling के बाद, if you want to discuss ना, there will be the one concept is called nothing, it is just a decision theory. यहीं पे लिख देता हूँ, right? Decision theory. This is very important. In the decision theory, that is called maximum a posteriori, maximum likelihood, how we are going to decode it, ki whether the 0 is transmitted or 1 is transmitted, like this type of question, how we are going to find out the threshold value by which we are going to discuss. So decision theory is basically based on the PDF. They will give you the PDF, and according to the PDF we have to find out the VTH. According to the VTH we have to find out the probability of error, right? Maybe the filter is also basically given there, and one is called, suppose matched filter is there, matched filter is used, output of the matched filter, all will basically come under the decision theory chapter only, right? और ये बहुत important है यार. From here everywhere they are asking the one questions, right? Decision theory, MAP, ML, maximum likelihood, maximum a posteriori, how we are going to find out the threshold, because threshold value play a very critical role to find out ki how much error is basically there in the system, right? Or what should be the probability of error in the system. Then matched filter, already we know that matched filter is basically used to increase the what? Signal to noise ratio, right? So matched filter is also important. And just after that, if you want to discuss, there will be the information theory. In the information theory, you can feel the question based on the entropy, okay, question based on the probability, that is condition or probability or entropy कह देते हैं, entropy लिख देता हूँ. Entropy means maybe the conditional entropy, right? Mutual entropy, joint entropy, like that type of question we can expect in the entropy. Then mutual information, then channel capacity, how we are going to find out the channel capacity, right? So these type of, for the different type of channel, this one is important in the information theory. Apart from this, there will be the one thing more. In the information theory itself, the one topic is there, that is called coding technique. In the coding technique, if you want to discuss mainly the Hamming code. Hamming code is important, but Hamming code last year already the one question they asked in the Hamming code. So in this time, cyclic redundancy code, CRC code is very important. And how much error correction and error detection and error correction, detection and error correction. Error detection and error correction. That's what basically we can say that in the digital communication the mostly, and definitely the one question we can expect into the based of the probability of error, right? So हमेशा ध्यान रखना probability of error. We'll discuss few questions also, right? Sir, आज सुबह आप Surjit. Okay. So this is the important topic, guys, from where we can expect the question, right? Okay. So let's start with the pulse code modulation. Let's start with the pulse code modulation. और आप लोगों को तो मैंने बोला ही था कि when the 50 people will join the session, then only will start, but only 33-35 people are basically there. So what should, but आप लोग आए हो तो मैं नहीं चाहता हूं कि जो आए हैं उनका नुकसान हो जाए. So few concept, but it is short. Entire digital communication is not going to be finished, right? I will discuss everyone. In the pulse code modulation, you have to remember the few formula, right? The few concept regarding to the pulse code modulation. The first one is called, sir, how we are going to find out the L, quantization level. Quantization level always should be less than or equal to 2 raised to power n. So here we have to remember कि L max, maximum quantization level, equal to nothing, it is just a 2 raised to power n, where n is equal to nothing, it is just a number of bits. number of bits. That's what you have to remember, the first one, right? Okay, right. Happy Pongal, right, Benali. Second one we have to discuss, that is called step size. Step size formula is called, we can write the delta equal to dynamic range of the signal, that is called peak to peak upon L, or we can say that this is also called peak to peak itself is called nothing, it is just a dynamic range of the signal. Dynamic range of the signal, and L, if you take the L maximum, L ही लिख देता हूँ, L we already know that is called 2 raised to power n, right? Okay, now if you want to discuss everyone. हाँ अंकित भाई, आज तो दही चूड़ा ही खाते हैं और खिचड़ी भी खाते हैं और पतंग भी उड़ाते हैं. Now this is called L, this is called step size. Now if you want to find out the quantization error, quantization error is called sampled value minus quantized value. Minus quantized value. Sampled value minus quantized value is called nothing, it is just a Shiva sir, in communication direct question will come analog distance. No, Shiva, it's not like a direct question they will come. Maybe they will correlate also. Crick expert prediction. Crick already have talked to the one of the, you can say that the professor of IITs, that is yesterday, right? और जो बात हुई थी वो समथिंग एल्स, वो तो किसी और रीजन से, कुछ पर्सनल रीजन के रिगार्डिंग कॉल आया था. But in the end, sudden I have asked regarding to this, what should be the exam of going to be postponed or not. So he has given the idea कि today, कल उन्होंने बताया था कि before the Saturday you will get all the notification regarding to the gate 2023. And मैंने बोला एडमिट कार्ड का क्या है, बोला everything you will get before the Saturday. So आज Friday है, let's do the Saturday. So that's why I'm saying only either today or tomorrow you will get all the notification regarding to the gate 2022. And there will be the most probably, जो बातों से मुझे लगा कि एग्जाम पोस्टपोन हो रहा है, राइट, ओके, जो मुझे बातों से लगा है, राइट, ओके. द क्वांटाइजेशन एरर, बट अभी भी श्योर नहीं, उनकी 2 मीटिंग ऑलरेडी, दे हैव 2 मीटिंग हैपेंड रिगार्डिंग टू दिस. ओके, सैंपल्ड वैल्यू माइनस क्वांटाइज्ड वैल्यू, ओके, बट कुछ कह नहीं सकते, उन्होंने ऐसे ही हिंट किया, पर कुछ श्योरिटी नहीं है उसके लिए कि एग्जाम पोस्टपोन होगा. उन्होंने मतलब जाते जाते बोला नहीं भी हो सकता है, राइट, ओके. सो सैंपल्ड वैल्यू माइनस क्वांटाइज्ड वैल्यू, राइट, ओके. शुभम, नेक्स्ट इन द पार्ट 3 विल डिस्कस द रैंडम, नोट, आई विल नॉट डिस्कस द रैंडम वेरिएबल, आई विल डिस्कस द रैंडम प्रोसेस ओनली, राइट. सैंपल्ड वैल्यू माइनस क्वांटाइज्ड वैल्यू. फोर्थ वन, इफ यू वांट टू डिस्कस अबाउट द क्वांटाइजेशन एरर, मैक्सिमम क्वांटाइजेशन एरर, मैक्सिमम quantization error, that is called delta by 2. This is called maximum quantization error, is called nothing, it is just a delta by 2, right? अरे आशुतोष सर, a very good morning, how are you आशुतोष सर, कैसे हैं आप? So guys, among us आशुतोष सर is also here. आशुतोष सर, स्वागत है आपका सेशन में, right? Okay. Fifth one, if you want to discuss, so first one is called L, second step size, third quantization error. Fourth one, we can say that maximum quantization error, that is called delta by 2. Somewhere they are mentioning plus minus delta by 2, but we are taking the mode only, right? That's why I'm writing the delta by 2, right? Correct expert, if you want to get the good marks into the mock test, you have to analyze whether you are doing the mistake. You have to find out the area where you are going to do the mistake, mainly you are going to do the mistake, and work on that. We have enough time, don't worry about that, right? Okay, maximum quantization error. इसके बाद if you want to discuss about the quantization power, quantization noise or quantization error, quantization noise power. Quantization noise power, if the uniform quantization is given, uniform quantizer is given, directly we can write delta square upon 12. Delta square upon 12, that is called quantization noise power. Apart from this, everyone, right? Yes. Okay. Thank you, Benali. Thank you. So this is called nothing, quantization noise power delta square upon 12. Apart from this, if you want to discuss the next one, how we are going to find out the signal to noise ratio, right? इसी के अंदर एक signal to noise ratio के अलावा fifth, sixth one is called sir bit rate. Bit rate is called nothing, it is just a RB. Bit rate, भाई साहब power cut everyone. Bit rate is called RB. RB is called nothing, it is just a NFS. स्ट्रेंथ भी कम आई है और देखो लाइट ने भी साथ नहीं दिया है. अगेन आई एम स्टार्टिंग एवरीवन. जस्ट गिव मी 1 minute. नो इश्यूज. देखो whenever we will discuss about the bandwidth ना, bit rate is called nothing, it is just a NFS. Bit rate is called nothing, it is just a NFS. And whenever you want to discuss about the after the NFS, you want to discuss about the bandwidth. Bandwidth, there are two type of formulas there. One is called minimum bandwidth and the second one is called maximum bandwidth. Whenever they will use the word bandwidth only, then you have to use the bit rate, and bit rate is equal to the bandwidth. But then whenever they are using the word minimum bandwidth, the minimum bandwidth will be always RB by 2. And if there will be the roll of factor is there alpha, then the bandwidth will be always RB by 2 1 plus alpha. RB by 2 1 plus alpha. One more time, let me take it. Okay. Bhai sahab, I have to reschedule this class, guys. Bandwidth is called nothing, it is just a RB by 2 1 plus alpha. And based on that we have to done some questions we have to do, but how is it possible? No issues. मैं बोला था ना 50 स्ट्रेंथ कर दो. Even the electricity, you can see the department want at least 50 people. Good morning Harshit. One more time let me try. After that I have to reschedule this class, guys, right? For the tomorrow at 10 p.m. If this class is not going to be happen, then tomorrow 10 p.m. we are going to take the class. And we'll start with the digital communication only, and entire digital communication will cover. But before that I will request all of you, please share among all of your friends. कल के सेशन के लिए भी सबको बता देना, so that more and more people will join the session and get, because देखो whenever the more people are coming ना, then we are feeling very energetic towards that, and we'll take the session whatever we have a content we guys are basically going to provide you, right? हम सारे के सारे फैकल्टी यही चाहते हैं. बट होता क्या है, even none of the people at this particular moment know about that कि whether the exam is going to be postponed or not, but they have mentally set like that कि no, exam is definitely, it is going to be postponed. And believe me, अगर मेरे से पूछोगे तो मैं चाहता हूँ वो डेट है ना उससे भी प्रीपोन हो जाए, 25 को ही आ जाए. अब people who are going to, because the toppers who are doing the preparation ना, they will always prepare whether the exam is going to be postponed or not. वो already आपको पीछे छोड़ देंगे यार. जो लूज हो गए कि सर मेरे से नहीं हो पाएगा प्रिपरेशन सर, या फिर मेरे पास तो टाइम है सर, विल डू इट, राइट? एंड बिलीव मी गाइस, द 90% हैव पीपल हैविंग द मेंटालिटी लाइक दिस कि सर वी हैव एनफ टाइम सर, विल डू इट बिकॉज एग्जाम इज गोइंग टू बी पोस्टपोन. एग्जाम इज गोइंग टू बी पोस्टपोन ना, देन इट इज गोइंग टू बी पोस्टपोन नॉट ओनली फॉर यू, द एग्जाम इज गोइंग टू बी पोस्टपोन फॉर दोज स्टूडेंट ऑल्सो हु आर ऑलरेडी प्रिपेयरिंग फॉर द सीरियस मैनर. सो द एग्जाम, इफ द एग्जाम विल पोस्टपोन ना, तो गैप आप में और उन स्टूडेंट में बहुत ज्यादा बढ़ जाएगा जो सीरियस है, बिलीव मी, राइट? One more time, let me try. Yes. भाई पावर आ गई है, कोई इशू नहीं है. ओके, सो लेट्स स्टार्ट गाइस. बिल्कुल अमृतांशु. So guys, always try to, that's why I'm just giving you the idea कि whenever you are preparing for the any particular exam ना, do not, if अगर आपके मन में ये आ जाता है कि सर एग्जाम आगे हो जाएगा, सर मैं थोड़ा सा रुक जाता हूं, तो आपको पता भी नहीं है कि आप अपने आप को करियर में कितना पीछे ले जा रहे हो, राइट? और जो लोग रिकॉर्डेड में देखेंगे ना, बिलीव मी गाइस, मैं आप लोगों के लिए बात कर रहा हूं ये चीज, राइट? कोई बोलेगा नहीं सर मैं तो जीनियस हूं सर, सो नो इश्यूज, गेट का रिजल्ट आएगा तो और डिस्कस कर लेंगे अपन। अरे ये क्या हो गया? ओके, सो वी हैव टू वेट फॉर द सम टाइम गाइस, 2 or 3 मिनट्स। तब तक मैं आपको थोड़ा सा बता देता हूं द इंफॉर्मेशन इन द डिजिटल कम्युनिकेशन। फर्स्ट वी हैव स्टार्टेड द पीसीएम। इन द पीसीएम सिस्टम, pulse code modulation system, we have discussed about the what, the first one, that is called L should be less than or equal to 2 raised to power n. Then we have discussed the second one, that is called nothing, it is just a step size, or step size is called nothing, it is just a step size is called nothing, it is just a dynamic range of the signal divided by L, that is called nothing, it is just a step size. Then we have discussed the third one is called, that is called quantization error. Quantization error is called sampled value minus quantized value is called quantization error or quantization noise. Then we have discussed the quantization noise power or maximum quantization noise power, noise, that is called plus delta by 2 we are discussing. And then we have discussed the quantization noise, you can say that. Then we have discussed the quantization noise power, that is called delta square upon 12. Delta square upon 12. After that, if you want to discuss about the bit rate, that will become nothing, it is just a n into fs, nfs. N is called number of bits associated with the each sample, and fs is called nothing, it is just a sampling frequency, right? That is called nfs. Just after that, if you want to discuss about the bandwidth, bandwidth is called rb equal to nothing, it is just a nfs. Bandwidth is called nothing, it is just a rb by 2. If the minimum bandwidth, if they were asking, then rb by 2 is the minimum bandwidth. If maximum bandwidth they are asking, then rb itself, bandwidth equal to nothing, it is just a rb. When roll-off factor is associated, then bandwidth is called nothing, it is just a rb by 2 1 plus alpha, right? Alpha equal to 0 for the perfect rectangular pulse, and for alpha equal to 1 if the spreading nature is basically there, right? So according to the alpha we have to put the values and we have to choose the answer, right? Okay, just after that, if you want to discuss, that's what we have discussed. Okay, after that, how we are going to find out the signal to noise ratio. For the signal to noise ratio, if you want to discuss guys, then that will depends what formula we have to use the signal to noise ratio. It will depends upon the one value, that is called what should be the nature of the signal. That will depends upon the nature of the signal, right? Okay. Oh. What is happening? Okay. Okay, let's again write PCM फटाफट फॉर्मूला लिख देते हैं जो हमने अभी डिस्कशन किया था. Sir, first if you want to discuss about the L should be less than equal to 2 raised to power n. L maximum is called nothing, it is just a 2 raised to power n. Second one is called step size, that is called nothing, it is just a dynamic range or peak to peak signal divided by L. And peak to peak signal itself is called nothing, it is just a dynamic range divided by L. Third one, if you want to discuss, ki sir, quantization error. Quantization error, if you want to find out, this is called sampled value minus quantized value. Sampled value minus quantized value is called nothing, it is just a quantization error. Fourth one is called quantization error, L delta WT quantization error. Now if in the fourth one, if you want to discuss, this is called quantization noise power. Quantization noise power or maximum, we can write maximum quantization error maximum, that is called delta by 2. Fifth, we have discussed for the quantization error, right? और इसको लिख देता हूं power, quantization noise power, that is called delta square upon 12 for uniform quantization. for uniform quantizer. This is the answer, right? Okay. वन लाइफ जो फॉर्मूला बता रहा हूं, जो अप्रोच बता रहा हूं और जिस पर जो हम क्वेश्चन सॉल्व करेंगे, ट्राई टू अंडरस्टैंड दोज कंसेप्ट, राइट? उसको समझ लीजिए, आपका काफी कुछ सही हो जाएगा, कोई दिक्कत नहीं, राइट? ओके, नेक्स्ट अगर मैं फिफ्थ की बात करता हूं दोस्तों, फिफ्थ चीज आपको क्या याद रखनी है इसके अंदर, क्वांटाइजेशन, इसके अंदर क्वांटाइजेशन ऑफ पावर के बाद कि सर अगर मान लीजिए आपके पास ये चीज हो गई, सर बैंड, आपके पास बिट रेट क्या होगा? बिट रेट का मतलब होता है सर बिट्स पर सेकंड। जब भी कभी रेट की बात हो जाए मतलब पर सेकंड की बात होगी कम्युनिकेशन में। So we are discussing about the bit rate, means the unit is bits per second. Bits per second. How many bits the transmitter are basically sending in the per second, that is called nothing, it is just a bit rate. And always if you want to find out the bit rate RB, that will become nothing, it is just a NFS. N is called number of bits, N is called number of bits per sample. Sampled, and Fs is called nothing, it is just a sampling frequency. And Fs is called nothing, it is just a sampling frequency. Any minimum? No, Shiva, no. Maximum ही होता है, minimum तो कुछ भी हो सकता है ना. Minimum will depends upon the what? Minimum should be the zero. There will be the no error. The sampled value itself present and the quantized value, so there will be the no error is there. So minimum quantization formula is not, that will be the directly zero you can feel. Minimum is going to be happen what? When sampled value and quantized value both are basically same. So quantization error is zero. Now sixth one, if you want to discuss everyone. Now there will be the lots of confusion in this, guys, right? Everyone try to understand. When bandwidth is asked, now there are two concepts there. Maybe the minimum bandwidth or maybe in the question maximum bandwidth if they're asking. Suppose they're asking about the minimum bandwidth. Always you have to use the formula RB by 2 or NFS by 2. And whenever they will ask about the maximum bandwidth formula, we have to use the RB only, that is called NFS only. So whenever in the question they are asking about the bandwidth, you have to be very, very careful whether they are asking the minimum bandwidth or maximum bandwidth, right? Okay, one thing more. Apart from this, everyone. Seventh one, if you want to discuss, guys, in the same manner, here if you want to discuss. Seventh one, कि sir, if roll-off factor is given, if alpha is called what? Roll-off factor. If roll-off factor is basically mentioned, guys, then we have to use the bandwidth formula. Then we can say that bandwidth formula is called nothing, it is just a RB by 2 1 plus alpha. RB by 2 1 plus alpha. Let they are asking ki alpha equal to 0 for what? Rectangular pulse. Then alpha equal to 0. Then your bandwidth is called nothing, it is just a simple RB by 2. That will up, right? RB by 2. And when bandwidth is, or when alpha equal to 1 is basically given, alpha equal to 1, this is called 100% excess bandwidth. 100% excess bandwidth. Alpha equal to 2. Then bandwidth, if you want to write alpha equal to 1 there, it will become nothing, it is just a RB. And always you have to remember कि alpha value lies between 0 to 1 only. Right? आप ऐसे समझ लीजिए. Suppose I am writing this is called alpha equal to 0. This is called alpha equal to 0.5. So this one is called F naught. Suppose I am writing this is called F naught and this is called minus F naught. So it will become 50% excess bandwidth. 1.5 F naught minus 1.5 F naught. And now next. This is called alpha equal to 1. It will become 2 F naught. This will become minus 2 F naught. That's why we are writing the bandwidth is just a double, right? That's why it is called 100% excess bandwidth, alpha equal to 1. I'm writing into the frequency domain. The time domain, you are absolutely correct. Ishika, the same nature is going to be happen opposite in the reverse manner if the time domain signal is given. I am discussing about the frequency domain. Because in the time domain, if you are sending the, you can say that the sampling function, right? Okay. Okay, now if you move into the next, right? Okay. Alpha equal to Roloff factor, right? This one is called. Now everyone try to understand. So Ishika, are you getting my point? Ishika, respond for everything. Ishika. Sir, gate postponed, latest update. Gate is postponed, latest update for 1 month. अच्छा जी, बहुत ही लेटेस्ट अपडेट दे रहे हो यार. Ganesh, where you have seen this 1 month update? Because I am not saying this 1 month postponed is basically happened. Latest update. Where you have seen? It is going to be postponed by the 1 month. But where you will have seen? In the site it is not uploaded yet. मतलब कुछ भी. अरे अमृतांशु, कुछ लोग ऐसे होते हैं जो टाइम पास के लिए आते हैं, जिनको कोई दुनिया में क्या चल रहा है उनसे कोई मतलब नहीं है, बस आ गए और खाली टाइम पास करवाओ. ऐसे ही बड़े लोग बड़े होकर ये पॉलिटिशियन बनते हैं. चलिए आगे आइए एवरीवन. राइट, ओके, नाउ दिस इज कॉल्ड अल्फा इक्वल टू Roloff factor. दिस वन इज, वी कैन से दैट. ओके, नाउ 7th, 8th, if you want to discuss about the dynamic range, everyone, and how we are going to find out the signal power. Because for the signal to noise ratio, signal power is required. So if you want to find out the signal power, always you have to remember either RMS ka square is called signal power. Square of the RMS value is called nothing, it is just a signal power. Right? RMS ka square. Otherwise, if the PDF is given, then you have to do what? If the PDF is given, then you have to do one thing. अगर PDF मेंशन है, देन मीन स्क्वायर वैल्यू, और ये तो RMS हो गया. मीन स्क्वायर वैल्यू इज सेल्फ इज कॉल्ड नथिंग, इट इज जस्ट ए सिग्नल पावर. राइट, ओके. सो वी हैव टू फाइंड आउट द सिग्नल पावर. एनीथिंग, राइट, बाय द एनी अप्रोच यू हैव टू फाइंड आउट द सिग्नल पावर ओनली. एंड नाउ इन 9th, if you want to find out the signal to noise ratio, then you have to find out the signal power. Individually you have to find out. Upon noise power, individually you have to find out. Signal power divided by noise power is called like this. Sometime if the noise PDF is also given, direct the formula is not given, noise PDF is also given. If the noise PDF is given, guys, if noise PDF is given, then you have to find out कि noise power x minus xq का whole square f of x dx. Sir, that what should be the value xq? Xq is called quantized value. If PDF is given, then quantized value is also given. So sampled value minus quantized value itself is called power. So you have to do the square. This is called like this, right? And now, suppose if nothing is mentioned and directly you have to solve the question. How we are going to do it, everyone? If nothing is mentioned and directly we have to solve this question, ना, तो आपको एक formula याद रखना है always. 11th, always you have to remember the one formula, guys. For the signal to noise ratio, always 3 into मैसेज सिग्नल का पावर 3L स्क्वायर, मैसेज सिग्नल का पावर अपॉन पीक वैल्यू ऑफ मैसेज सिग्नल का स्क्वायर. यू हैव टू रिमेंबर दिस फॉर्मूला. दिस इज a universal formula we are going to utilize everywhere. Whether the signal is sinusoidal or non-sinusoidal or any signal is given, you have to utilize this concept to solve the question, right? Again I am writing कि notation of this one is called nothing, it is just a signal power, message signal power. Message signal power. MP is called peak value of message signal. Peak value of message signal. How we'll do it? Everyone try to understand. Here if you want to write, simple. 3L square, and this one is the formula. Now for the, this is applicable for the any type of message signal. Suppose I am giving you the first. Let message signal is sinusoidal, that is called AM cos 2 pi FMT. Let message signal is AM cos 2 pi FMT. Then what should be the power of the message signal? Sir, power of the message signal RMS ka square itself is called nothing, it is just a power. RMS is called AM by root 2 ka square itself is called nothing, it is just a power. And now if you want to find out what should be the peak value of message signal, sir, peak value of the message signal is called nothing, it is just a AM. AM is called peak value of message signal. And now if you want to find out, signal to noise ratio for the sinusoidal signal, it should be 3L square. And what should be the value here? We can say that this one is called AM square by 2 upon peak value ka square, that is called AM square. AM ne AM ka kar diya murder khatak, and this will become 3 by 2 L square. L, we already know that the maximum value of L is called 2 raised to power n. So it will become 2 raised to power 2n, right? So now in the dB, if you want to use the word, guys, in the dB, if you want to write 1 point, or we can say that 10 log 10 base of 3 by 2 plus 10 log 10 base of L square. L also we can write 2 raised to power 2n. So we can say that 2 raised to power 2n, 2 raised to power 2n. And if you solve it, you will get nothing, it is just a everyone. You will get nothing, it is just a here we can write this is called 1.76 and this is called 6n dB. In the dB if you want to write. So whenever the people are using this formula 1.76 plus 6n dB, this is not necessary that this formula is used for the everywhere. This formula is restricted towards only for the message signal is sinusoidal. If message signal is something else, we are not able to find out, right? Shiva, DC power. Shiva, where you want to find out the DC power? I am writing simple total power for this signal, right? Now suppose if the message signal is not sinusoidal, if the message signal is square, electromotion, right? A very good morning. Suppose if the Ripakshi, when the message signal is not sinusoidal, suppose message signal is given square pulse. How we are going to find out? If the message signal is given like this square function, this is called AM, this is called minus AM. This one is called your message signal. And now if you want to find out the message signal power here, for the square function we already know that AM is square. Case 2 we are taking, the message signal is like this. And now what should be the value of this, everyone? If the message signal power is called AM square, what should be the peak value of message signal? This is also called AMs. Now, if you want to find out the signal to noise ratio, the formula already we know that 3L square. So message signal power divided by peak value of message signal ka square. This one sometime also called normalized message signal power. This one is also called normalized signal power, right? Message signal power. So we can say that 3L square, this one is called AM square, upon this one is called AM square, cancel out, you will get 3L square. And if you want to find out in the signal to noise ratio, in the dB if you want to find out, this will become nothing, it is just a simple 6n dB. There will be no need for what? 1.76. Simple we can say that, yes. Simple we can say that 6n dB. Suppose instead of this, if the triangular pulse is there, how we are going to find out? So if the triangular pulse is given, again we are going to find out very easily. Suppose I am giving you the triangular pulse like this. This is called AM and this is called minus AM. This is your message signal. And now if you want to find out the message signal power, this is called nothing, it is just a AM square by 3. And what should be the peak value of message signal? This is called AM. And now if you want to find out the power, guys, everyone, sir, how we are going to find out this one, M square T power? Already we have calculated. Sir, how we are going to find out the signal to noise ratio in dB? So signal to noise ratio dB is called nothing, it is just a, everyone, signal to noise ratio in the dB. If you want to find out 3L square, message signal power is called AM square by 3 upon peak value of message signal ka square is called AM square, khatak, cancelled out, and you will get, oh, it's not 3L square, yeah. Here you will get, everyone, 4 plus 6 and dB. You have to find out 4 plus 6 and dB, everyone. 4.77. Correct. We have done the mistake because 3 also we have to find out. No, log 10 base of 3 is called 4.77 plus 6 and dB. Here no need for this. This is the answer for this. Yes, correct, Ishika. And here there will be some derivation, right? Electromotion. We will solve that derivation also. Definitely. No. 10 log, not 20. Shiva, because everything is given in the terms of power only. When it is given in the terms of power only, then we have to use the 10 log, not 20 log, right? Okay. So now 3 cancel out. Now you will get L square. So here if you want to write into the dB, here if you want to write signal to noise ratio in the dB, then you will get 10 log 10 base of L square, and it will become nothing, it is just a 20, you can say that. This will become 6 and dB. This will become 6 and dB. Yes, Harshit. So hope everyone understood up to this portion. जो नए आते जा रहे सेशन को लाइक करते रहना भाई. Right. So this is called nothing, it is just a 6 and dB. Right. So we have discussed कि sir universal formula for finding the any signal to noise ratio for the pulse code modulation is this. That formula is varied according to what should be the nature of the message signal. But the standard formula we have to use this one. There will be the small derivation is also, but in this series there will be no requirement of that particular derivation. Right. So that's what the 11 concept we have discussed regarding to this. Now suppose one thing more, everyone. Sometime they will give you L and they'll ask about the H. Always you have to remember what should be the meaning of L. L is called quantization level, right? And generally L maximum we are writing like 2 raised to power n. So everyone try to understand what should be the value of n. N is called nothing, it is just a log 2 base of L. That is called n. What should be the meaning of L? N. N is called number of bits per sample. Number of bits per sample. And how many bits assigned to the per sample is also called entropy. If you remember, number of bits assigned to the per sample is also called what? Entropy. So sometime this N is also represented as a H. Entropy. Because entropy is also called average number of bits assigned to the per sample. Right? L is called number of level, but N is called number of bits per sample. How many bits is assigned to the per sample is called nothing, it is just a this, right? Okay. Hope you understood this point, guys. If you understood, now we are moving into the next, everyone. Suppose one question we are solving. That question is, the first question in front of you guys. An analog signal having the 5 kHz bandwidth is sampled at 1.5 times to the Nyquist rate, and each sample is quantized into one of the 256 equally likely levels. Assuming the successive samples to be independent, the minimum signal to noise ratio required for the error-free transmission using above scheme over an additive white Gaussian noise with the bandwidth of 10 kHz. It means the channel bandwidth is given, guys. What should be the channel bandwidth is given? Sir, bandwidth of the channel is given nothing, it is just a what? 10 kHz. Message signal bandwidth is given. FM, that is called 5 kHz. So everyone quickly solve this question. It's very per symbol और per sample मैंने लिखा ना, बात एक ही है, per sample symbol. Everyone quickly solve this question यार, quickly. Very easy question, not that much of tough. How we are going to find out the Nyquist rate? So Nyquist rate is called twice of FM. Twice of FM means 10 kilohertz. Twice of FM is called 10 kilohertz. Now, what should be the sampling frequency? 1.5 times to the Nyquist rate. 1.5 times to the Nyquist rate. 1.5 times to the Nyquist rate. 15 kilohertz. That is called sampling frequency. Okay. So 256 equal level is basically given. That is called 256. So from here, if you want to find out n is called nothing. It is just a 8. N is called 8. How we are going to find out the RB? RB is called nothing. It is just a NFS. C 36.12. Kishan has given the answer 36.12. Okay. RB equal to NFS. N is already we have calculated 8. And FS is called what? 15. तो कितना हो गया? kbps. That is called RB we have got. But in the question they are not asking about the RB. They are asking about the minimum signal to noise ratio required for the error-free transmission using the above scheme over an additive white Gaussian noise channel having the bandwidth 10 kilohertz. Now everyone look at here. Always we know that ki channel capacity should be always greater than the transmission bit rate. Then only the error-free transmission is going to be happen. So whatever the number of bits per sample you are transmitting and what should be the rate per second you are transmitting, the channel should have the capacity to handle more than that basically bits in a 1 second. Then only there will be the no error is going to be happen, right? Okay. How we are going to find out the channel capacity? Sir, bandwidth of channel log 2 base of 1 plus S by N. This is called channel capacity. But this S by N is not in dB. It is in normal value it is written. So should be always greater than what? What should be the transmission bandwidth we have calculated? 120 into 10 raised to the power 3 bits per second. Now if you want to discuss log 2 base of 1 plus S by N should be greater than 120 into 10 raised to the power 3 upon what should be the value? 10. 10 into 10 raised to the power 3 cancelled out, you will get 12. And now here you can solve this question also, guys. Log 2 base of, how we are going to solve it, everyone? Log 2 base of 1 plus S by N should be greater than 12. So 1 plus S by N, you will get 12 or 2 raised to power 12. 2 raised to power 12. And here if you want to find out the S by N should be greater than 2 raised to power 12 minus 1. But this is not in the dB. This is in the normal value. You have to find out into the dB. So signal to noise ratio in dB equal to 10 log of 10 base of 2 raised to power 12 minus 1. Solve it. And I think if you will solve it, you will get what? 39 or 36.12? 36.12. You will get 36.12 is the answer for this question, and that's why the answer of this question is nothing, it is just a C. Everyone respond yes or no. Understood? Write down yes or no. Everyone quickly respond, yaar. Everyone quickly respond yes or no. You will understand this question, how we are going to solve it, or do you have any doubt? And if you understood it, one more question I am giving you. An analog signal has the bandwidth of 4 kilohertz. Signal is sampled at 2.5 times to the Nyquist rate. Each sample quantized into 256 equal likely levels. The SNR is 10 dB. The bandwidth of the channel required for the, now they are asking about the bandwidth of the channel. Yes, clear, बहुत बढ़िया. If you understood the previous question, now you guys are going to give the answer of this question also very easily. If you understood the previous question, now everyone please see formula, read sir. See formula, read sir. B log 2 base of 1 plus, that is correct. That is called Shannon channel capacity. Shiva, this is called Shannon channel capacity. B log 2 base of 1 plus S by N. सर मिनिमम वाली कंडीशन एक बार बता दो. अब कौन सी मिनिमम वाली सचिन बता दूं? एरर फ्री टर्म्स में किसकी मिनिमम, कौन सी मिनिमम चाहिए तुमको कंडीशन? क्वांटाइजेशन एरर की किसकी मिनिमम कंडीशन चाहिए? ओके एवरीवन, जस्ट ट्राई टू सॉल्व दिस क्वेश्चन. यार अब देखो ये वही क्वेश्चन सेम है. वी हैव टू फाइंड आउट द आरबी फर्स्ट. How we are going to find out RB? That is called NFS. N is called what? 256, so 8. FS is called 2.5 times to the Nyquist rate. 2.5 times to the Nyquist rate. Nyquist rate is twice of the message signal frequency, 4 kilohertz. Solve it, you will get the RB. You will get the RB. अरे फ्री ट्रांसमिशन के लिए मिनिमम वाली कैसे बताऊं यार? मैक्सिमम ही होगा ना सचिन. तुम हो, ये सचिन तो भाई तुम हो, और ये एक मान लीजिए एक दूसरा आदमी है. ये सचिन तुम हो, ये सचिन है और ये राहुल है मान लो. यहां से बॉल पास होगी. तुम भेज रहे हो 10 बॉल 1 सेकेंड में, 10 बॉल इन 1 सेकेंड, पर इसकी हैंडल करने की कैपेसिटी है 5 बॉल पर सेकेंड. तो 5 बॉल तो कैच करेगा, 5 बॉल क्या हो जाएगा? बेकार हो जाएगा, राइट? दे आर नॉट गोइंग टू पास इट बिकॉज दिस वन हैविंग द लोअर कैपेसिटी. सो ऑलवेज इफ यू वांट टू पास दिस सिग्नल इन प्रॉपर मैनर, देन दिस पर्सन कैपेसिटी शुड बी ग्रेटर देन दिस वन. सपोज आई एम राइटिंग दैट दिस पर्सन कैपेसिटी इज C and this is the transmitting capacity is RB. So always C should be greater than what? RB होना चाहिए for the error free transmission. अब तुमको मिनिमम भी चाहिए इसमें. सिंपल तो कंसेप्ट है, मतलब ऐसा थोड़ी कि मैक्सिमम हो गया तो मिनिमम का भी निकालो, फिर थोड़ी देर बाद बोलोगे सर एवरेज का बता दो सर. That is the aptitude level things, right? Okay. Now you have to solve this question. Now if you remember this one, now channel capacity already we know that B log 2 base of 1 plus S by N, that is called Shannon channel capacity. So C should be greater than B for the error free transmission. So B log 2 base of 1 plus S by N should be greater than RB. Now here everyone, B should be what? Greater than RB upon log 2 base of 1 plus S by N. So we can say that this one, always try to understand this signal to noise ratio is given in the dB, but here always required into the normal value, not into the dB. So in the 10 dB, if you want to write into the normal value, 10 log x equal to given 10. So x is given what? 10 raised to power 1. So ये तो 10 ही बना, ये तो coincidence है, right? So 10 only. So now if you want to find out, इधर solve करिए, इधर रख दीजिए, you will get the value. And the people are saying the B, so I will go with the majority, B. $46250 hertz. Everyone, respond for this if you understood. और कुछ लोग धोखेबाज भी हैं, लाइव आ रहे हैं पर लाइक नहीं कर रहे हैं, पाप लगेगा, ध्यान रखना. Okay. So we can say that this is basically the formula where which we can expect the question. One thing more, when you can say that known or non-uniform quantization is given. Suppose non-uniform non-uniform quantizer is basically given. Suppose non-uniform quantizer is given with this one is called delta, step size is called delta 1, delta 2, delta 3. Non-uniform means what? The delta is going to be changed, right? Then we can say that then quantization noise power, then quantization noise power equal to upon 12 plus delta 2 square upon 12 plus the delta 3 square upon 12 plus delta n square upon 12 divided by, take the average value of this. This is called quantization noise power. You have to remember this one. This one is called nothing, it is just a quantization. Alright. Good morning, dear. This is called quantization noise power, right? For the non-uniform quantization. Okay. Now we are moving into that sir, what happens if the delta modulator is given? So everyone try to understand. In the delta modulator, only two type of question we can expect. One is called delta modulator, is also called 1 bit DPCM. This is also called 1 bit DPCM. DPCM means what? Differential pulse code modulation. So 1 bit DPCM itself is called nothing, it is just a delta modulator. In the delta modulator, two errors are there, guys. Two problems are there. And from here, they can ask the question generally, problem. One is called slope overload problem. Your slope overload distortion. One is called slope overload distortion. So what is happening to the slope overload distortion? So everyone try to understand. Suppose message signal is moving very fast and the slope of the quantizer is fixed. So what should be the slope of the quantizer? If you want to discuss about the slope of quantizer, delta upon TS. This is called slope of quantizer. And what should be the slope of message signal? So slope of message signal dm by dt. So this slope overload distortion is going to be happen when dm of t by dt means slope of the message signal maximum is greater than the slope of the quantizer. Then in the proper tracing is not possible. Then we are not able to trace the proper signal. And that's what this difference. This difference is called slope overload distortion. We want to track in the proper manner, but there will be some differences there. And that's what called slope overload distortion. How we are going to avoid the slope overload distortion? So everyone, if you want to avoid the slope overload distortion, then equality sign is going to be happen. Then we have to change the value of delta, that is called delta optimum upon TS. That's what basically required. So we can understand one thing more. Okay, sir, let m of t equal to am cos 2 pi fmt. Let m of t equal to am cos 2 pi fmt. Now, what should be the maximum value of this slope? Sir, am into 2 pi fm. This is called right maximum slope. So we already know that कि sir SOD slope overload distortion occur when what? AM 2 pi FM is greater than delta optimum upon TS. Then how we are going to avoid it? To avoid SOD, equal to sign is going to be happen. Means AM 2 pi FM should be equal to delta optimum upon TS. This condition is occurred, then we can say that we are going to avoid this slow power load distortion. That's what basically happened, right? Okay. चलिए आगे बढ़ते हैं. How it is going to be happen? So everyone, let's discuss the next, guys. Right? Okay. There will be the sun. It means to avoid the slow power load, to avoid directly, you can remember, to avoid SOD, dm of t by dt maximum should be equal to delta upon ts. That is the basically, we can say that if you want to avoid it, you have to remember this condition, right? Okay. And there will be the one more problem is there, that is called second one, granular noise problem. Granular noise problem is basically happening कि suppose samples value is called like this. Same sample magnitude value is there. Then what actually we want? We want either it will be represented by the 0 or by the 1. Right? If the same sample value is basically magnitude is 1, then it should be represented either by the 1 and then either by the 0. But when the same magnitude sample is there, then may be represented by 0, it should be represented by 1. Alternatively, it will be represented by 1 and 0. But we required if the sample value is same, then it will be represented by the either by the 1 or by the 0. But it is not happened here. Keep when the same number or same, you can say that magnitude samples are there, then successively it will be represented by 0 and 1 alternatively, right? And that's what the basically problem is called granular noise problem. If you want to, again, if you want to understand this problem with the example, we can understand like this. Suppose I am taking the message signal is like this. Sample is like this, no issues for that. Now it will trap, it will goes to the upward direction. Now again it will come to the backward because the sample is less. Again upward. It want to trace the signal. So if it's going above, then it has to come into the back downward. If it is a downward, then it has to go into the upward like this. So you can feel alternatively here the sample, if it is increasing, sample is represented by 1. It is decreasing, the sample is represented by 0. Again it is increasing, sample is represented by 1. Again it is a decreasing, sample is represented by 0. Again it is increasing, sample is represented by 1. So you can feel same magnitude sample is there, same magnitude sample is there, but alternatively it will be represented by 1, 0, 1, 0, 1 like this. And this is called problem. That is called nothing, it is just a granular noise problem, right? So Shiva, whatever you are asking now, that is the basically condition of this. When slope of the quantizer is greater than the slope of the message signal, then this type of condition is going to be happen, granular noise problem. And there will be the one thing more into the delta modulator, guys. Granular, right? Okay, how we are going to find out the signal to noise ratio. Signal to noise ratio. So everyone try to understand. But when the post reconstruction filter is basically given, when the post reconstruction filter is given, then how we are going to find out? How we are going to find out the signal to noise ratio, right? Into the what? Into the delta modulator. So always you have to remember, this is called 3 upon 8 pi square into Fs. Fs is called nothing, it is just a sampling frequency upon, this is Fm. Fm cube into Fm. And this Fm, small fm is called message signal, and this capital Fm is called nothing, it is just a post reconstruction filter, right? So again I am writing this one, you have to remember 3 upon 8 pi square into Fs cube upon Fm cube into Fm. This Fm is called message signal power, Fm is called post reconstruction filter frequency, and Fs is called sampling frequency. You can use here this one and you will get the answer. Use there and you will get the answer. Suppose I am asking one question, everyone. Suppose I'm asking the one question, everyone just give me the answer. The calculate the value of SNR, signal to noise ratio, for the DM delta modulation if 1 kilohertz signal sinusoidal sampled at 32 kilohertz without the slope overload problem. If the followed by 4 kilohertz, it means 4 kilohertz FS is given, FM. Filtered. What should be the SNR in dB? I'm not writing into the dB. Whatever the value you have to calculate, now after that you have to write into the dB. So FM is given 1 kilohertz sinusoidal, FM is given, message signal is given 1 kilohertz. Sampled signal is given what? 32 kilohertz. Without slope overload problem, what should be the signal to noise ratio? Signal to noise ratio 8 upon देखो 3 pi square. Sorry, उल्टा लिख दिया. 3 upon 8 pi square into what should be the FS? 32 into 32 into kilo है 3 3 6 3 9 into 10 raised to power 9 upon 4 है 4 into 4 into 4 into 10 raised to power 9 into 1 into 10 raised to power 3. You have to solve this question and then you have to, whatever the value you are getting, you have to write into the 10 log. Suppose this value you are getting into the X, you will get into the dB. Everyone understood? Write down yes or no, yaar. Write down yes or no if you understood it. Everyone, quickly. Nobody is responding. Respond, beta, everyone. And if you understood one more question I am giving you, everyone just give me the answer. What is the resulting SQNR, signal to quantization noise ratio, for a signal uniform distributed between -1 to 1 when the uniform PCM with 128 level is employed? You have to find out the signal to quantization noise ratio for this question. Everyone quickly respond it. Quickly. So how we are going to do it? Everyone देखो. -1 to 1 and it will become nothing, it is just a 1 by 2. This one is called resulting, right? Uniformly distributed between 1 to 1, right? Okay. The message signal is result, right? Signal is uniformly. Now if you want to discuss about the message signal power, how we are going to find out? So message signal power, mean square value of this. How we are going to find out the mean square value of this? -1 to 1 x square f of x dx, and if you do it 1 upon 2 x cube by 3 -1 to 1. So 1 का cube you will get ये 6 हो गया, 1 upon 6 is outside, and here if you want to write, this is called 1 -1. So you will get nothing, it is just a 1 by 3. Right, what is the power? Message signal power 1 by 3 watt. Now noise power, we already know that noise quantization noise power, quantization error power, this one, right? Noise power. This one I am writing signal power. The quantization noise power is called nothing, it is just a delta square upon 12. How we are going to find out the delta? So dynamic range of the signal upon L upon 2 raised to power upon 12. Dynamic range -1 to 1, that is called 2. Upon L is called, level is also given 128, means what? 8. No, 7. Yes, 7. नहीं, ऐसे क्या, L 128 ही लिख देता हूँ. So 2 upon 128 का whole square upon 12. This one is called quantization noise power. And now if you know the quantization noise power, so signal to quantization noise ratio, this is called nothing, it is just a signal power 1/3 quantization noise power. अब यार इसको और सॉल्व करें क्या, otherwise you will do it 2/128 का whole square upon 12. This one is there. You have to solve this value, and whatever the value you will get, this is the normal value. Suppose you are getting x, so S, Q and R in the dB, 10 log of x, 10 base of x. This one we have to find out. Everyone quickly respond for this. Quickly respond for this. Nobody respond. A 42. I don't know whether you have solved the correct or not. In this method, if you are solving, then whatever the answer you have to choose it. I have given the formula, approach, everything I have discussed, right? I don't remember what should be the answer of this question. Okay, Raminder, Shubham, Sonali, Kisan, बहुत ही बढ़िया. Now if I will ask one more question, guys. The input to the linear delta modulator, the input to a linear delta था ये, delta modulator having a step size of 0.628 is a sine wave with the frequency FM and the amplitude AM. If the sampling frequency Fs equal to 40 kHz, then the combination of AM and FM where the slope overload distortion take place. When the slope overload distortion is going to be take place? Slope overload distortion, SOD, is going to be happen when dm of t by dt, message signal maximum slope, is greater than delta upon ts. Message signal maximum slope is equal to what? The delta upon ts. That's what basically happened. Now we can write what should be the value here. Message signal slope is there, so we can say that, or we have solved it. We already know that 2 pi am into fm should be greater than delta upon ts or delta into fs. This is the condition where the slope overload distortion is going to be happen. Sir, can we use delta square upon 12? हाँ Ishika, I have used ना delta square upon 12. मैंने यही तो यूज किया, delta square upon 12. But how you will get the delta? That is the problem. Ishika Sharma ji, how you will get the delta? So delta is called nothing, peak to peak value upon L. That's what we can say, that delta. So peak to peak value is called what? Message signal is moving from -1 to 1. So peak to peak value is 2. That's why I'm taking the 2 upon level is called 128 upon 128 का square upon 12. Same formula वही तो लिखा है मैंने. And this is a delta modulator. It's not PCM. So here you want to discuss AM into FM should be greater than delta into Fs upon 2 pi. So if you want to write delta is called 0.628. इसको नीचे लिख देता हूं. Fs is called 40 kilohertz. 2 into 3.14. So देखो इसको हटाता हूं 100, इसको हटाता हूं 1000. This part cancelled out. 2020 cancel out. 1010 cancel out. 4 kilohertz. If the multiplication of AM into FM is the greater than 4 kilohertz is there, kilohertz into volt. If the multiplication of AM into FM is greater than 4 kilohertz, then definitely the slope overload distortion is going to be happen. So you have to multiply it. If you multiply it, 8 into 0.3, 2.4 kilohertz per volt. Greater than 4 is required. 6 kilohertz per volt. Yes. So definitely B is the correct answer of this question. Yes. So everyone has given the correct answer of this question. बहुत ही बढ़िया. Now if you understood it, now we are moving into the next. One more question for you guys, everyone. A delta modulator is designed to operate on a speed limited to 2.8 kilohertz. The sampling rate is 10 times to the Nyquist rate. Step size is 120 millivolt. The modulator is tested with the sinusoidal signal of 1.2 kilohertz. The maximum amplitude of the test signal to avoid the slope overload distortion will be. Explain how. यार शिवा, आप जो क्वेश्चन पूछ रहे हो ना, how the quantization we are going to perform, that's what the question we are asking. Suppose the message signal is basically happened like this. Now we have to do the first sampling we can do like this, like this, like this. This is a sample. Now we have to take the one threshold value. Suppose I am taking threshold value. This is the threshold value. And now we have to take the one bit I am taking. This is called level 1 and this is called level 2. ये आपका level, suppose this is called 4 volt is there. This will become 2 volt and this is called 6 volt. This is called your threshold value. So if the message signal between 0 to 4 is there, we have to keep it at 2 volt and we have to encode the bit 0. If the message signal lies or sampled value lies between 2 to 4 volt, then we have to keep it at, when the message signal is basically lies bit above 4 volt, we have to keep it at 6 volt and we have to apply the 1 bit to this. Now you can feel this sample value is what here. So this is lies between 0 to 4 volt. This lies between 0 to 4 volt. So we have to keep it at what? This one. So this one is called quantized level, quantized value. And this one is called sampled value. So if you are keeping this sample, you are just put this sample into this particular instant. It means original value is this, but you are keeping into the quantization. We have to keep the sample to the predefined value. So predefined value is this. So this one is called nothing. It is just an error. So this is called sampled value minus quantized value. That's what the error is basically present. Shiva, are you getting my point? Shiva. Now look at this question, guys. Look at this question, everyone. बहुत ही बढ़िया. A delta modulator is designed to operate on speed limited to 2.8 kilo. अब तो solve कर सकते हो यार. The maximum amplitude of the test signal to avoid the slope overload distortion. Everybody responding into the B. Okay, let's solve this question. B or A? देखो, 10 times to the Nyquist rate. Fs we know that 10 times to the Nyquist rate. Operate on the delta modulator is designed to operate on the speed of 2.8 kilohertz. 2.8 kilohertz. So into 2.8 kilohertz. .6 56 kilohertz, right? Fs is called 56 kilohertz right now. Delta is called 120 millivolt. ठीक है. The modulator is tested with the sinusoidal signal of 1.2 kilohertz and the maximum amplitude to avoid the distortion. कौन सा distortion? Slope overload distortion. So we already know that AM into FM into 2 pi. To avoid, so equality sign is there, delta into Fs. So AM equal to delta into Fs upon Fm into 2 pi. Delta is called what? 120 into 10 raised to power minus 3. Fs is called 56 into 10 raised to power 3. Upon Fm is called 1.2 into 10 raised to power 3 into 2 into 3.14. And if you'll solve it, you will get the value what? 0.891 volt. That is called A. A is the absolutely correct answer of this question. A is the absolutely correct answer of this question. बहुत बढ़िया. जो नए आते जा रहे हैं वो लाइक करते जाना बेटा. ऐसा लाइक में धोखेबाजी नहीं होनी चाहिए. Right? Okay. Now one more question to you, everyone. One more question to you. Consider a linear delta modulator. Consider a linear delta modulator system designed to accommodate the analog message signal limited to bandwidth 3.5 kilohertz. A sinusoidal test signal of amplitude AM equal to 1 volt and frequency FM equal to 800 hertz is applied to the system. The sampling rate of the system is 64 kilohertz. The granular noise power would be, we know that how we are going to find out the slope overload distortion or slope overload problem to avoid it. Already we have discussed. But now they are asking about the granular noise power. Sir, how we are going to do find out the granular noise power? So everyone, directly we are solving this question. देखो, always you have to remember granular noise power equal to, देखो आपके पास क्या 3 delta square into bandwidth, right? Bandwidth upon 3fs. This one you have to remember. कि sir granular noise power again there will be the very small derivation for this, but not required here. Delta square b upon 3fs. That's what called nothing. It is just a what? Granular noise power. So if you want to write here delta, already we know that delta दे रखा ना. Delta is not mentioned. No issues. Delta we are able to find. Already we have solved the delta. यही question था क्या? नहीं. Okay, no issues. Delta we have to find out, right? Delta is not given, then sinusoidal is given, so 2am upon L. L is also given, or L is also not given. Dun. L should be always mentioned in the problem, no issues. The sampling rate is 64 kilohertz. Okay, bandwidth is given, analog signal limited to the 3.5 kilohertz. A sinusoidal signal is amplitude is 1 volt and the frequency FM is called 800 hertz is applied to the system. The sampling rate is, so the system is 64 kilohertz. हाँ तो हो तो जाएगा. You will get the value of N. Everyone, how we are going to get the value of L? Everyone just give me the answer. How we are going to solve this question? First you have to find out the value of a delta. And delta we already know that peak to peak value upon what? Peak to peak value upon L. So we require L or we require N. Anything we can find out. How we are going to do it? Everyone try to understand. So message signal is band limited to what? The analog signal, direct delta modulator is basically designed to handle the bandwidth of accommodate the analog message signal limited to 3.5 kilohertz. A sinusoidal test signal of amplitude AM is equal to 1 volt and frequency FM equal to 800 volts is applied to the system. The sampling rate is given 64 kilohertz. ठीक है? 64 kilohertz. So the sampling is given 64 kilohertz. And to avoid the slope overload problem, if you want to write, so here we have to do AM. First, how this problem is going to, because delta is going to be fixed. So AM into 2 pi into FM first equal to, for the optimum what should be the required, so that delta into Fs. So now can anybody give me the answer? What should be? AM is given, FM is given, Fs is given. Can anybody find out the value of delta? Direct delta is given, no need for the L. How? So delta is called AM into 2 pi into FM upon Fs. So AM is called what? 1 volt. 2 into 3.14 into FM is called message signal frequency is basically given what? Applied to this, the sampling rate. So we have to apply this one, 800 hertz. Upon what should be the value? 64 kilohertz. 64 into 10 raised to power 3. Can anybody give me the answer? What should be the delta value you are getting? Yes, definitely. So can anybody give me the answer? What should be the delta value you are getting? Nobody is calculating. ये देखो यहीं पे लिखा हुआ ये delta. I am directly taking 78.5 millivolt. Now we already know that delta square into B upon 3Fs, put over there and you will get the granular noise power. 1.123 into 10 raised to power minus 4. Right? Everyone. 1.123 into 10 raised to power minus 4. So 1.123 into 10 raised 1.12 10 raised to power minus 3. Yes, D is the absolutely correct answer. Correct, 78.5 millivolt. Absolutely correct. So we have calculated this one very easily. Now I'm asking one more question, everyone. But Right, in the next part we have to discuss about the ASK, FSK, PSK. But before going to ASK, PSK, FSK, I have to discuss the ASK, PSK, FSK also, constellation diagram. But let me discuss the first information theory. Then we'll discuss those portions, right? In the information theory, guys, we already know that the probability and information are basically inversely related to each other. If any symbol having the more probability, then the information contained by that symbol is very less, right? It's very less. Now, it means I and P are basically inversely related to each other. I is called information, P is called probability. So I equal to log 2 base of 1 upon P. If you want to remove the proportionality constant, we can write I equal to log 2 base of 1 upon P. And that's what basically answer you will get into the bits. If you use the 10 base 10, then it will become Hartley. If you base log E, then it will become natural. So according to the base, the unit is going to be changed. But in our digital communication, always we are discussing about into the bits only. So I will use always information is called nothing, it is just a log 2 base of 1 upon P. Now everyone try to understand. This is called information. Now suppose there are n symbols are there. Suppose there are n symbols are there. x1 having the probability px1. Now suppose there are the x2 symbols are there, and occurrence of the x2 symbol having the probability px2. Now there are x3 symbols are there, and the occurrence of this probability of the x3 is px3. Now xn symbol is there, and the occurrence of the xn symbol is pxn. Then we can say that always self, or we can say that self information. Self information means information associated with the individual symbol. Self information. If you want to find out the information for x1, ixn, it will become log 2 base of what should be the probability of px1 of the occurrence? Px1. In the same manner, if you want to find out what should be the information associated with the x2, that will give you nothing, it is just a log 2. What should be the occurrence of the symbol x2? Px2. And always the unit is in the bits. This is also the unit into the what? Bits. So in the bits unit you can feel. Now everyone try to understand. This is also in the bits, this is also into the bits. So now one thing more I want to share. If you up to this portion everything is clear, now everyone try to understand. So xi, for the any particular symbol, if you want to find out what should be the probability is there, or self information is there, log 2 base of 1 upon p of xi. Sir, what should be the meaning of information? Information will give you the idea how many bits are basically assigned to particular symbol. So we have to use the calculator properly here because of this. Yes, definitely lucky. So this information is nothing. According to the symbol, they will give you how many bits are basically assigned to this. Suppose where the example, if I am taking x1 equal to 1 by 4 and x2 is also 1 by 2 and x3 is called 1 by 4. Suppose three probability this is given. Ki x1 having the probability 1 by 4, x2 having the probability 1 by 3, x3 having the probability 1 by 4. Now if you want to find out what should be the information associated with this. So ix1 equal to log 2 base of 1 upon 1 by 4, and that is called nothing, it is just a 2 bits. So what should be the meaning of this? The meaning of this one is x1 symbol is basically assigned out x1 information, x1 having the in bits 2 bits, or we can say that we have to assign 2 bits to the x1. Suppose for the x2 if you want to find out, this is called x2, and we can say that log 2 base of 2. So this is called 1 bit. It means x2 symbol having the 1 bit only. It means we have to assign 1 bit to the x2 symbol. So this will give you how many bits are basically individually assigned to all the symbols. That is basically given by the self information. But in the communication we are not interested into the self information, because how many bits are individually related to the particular symbol, we are not interested in it, because we are not transmitting only one symbol or two symbol. We are transmitting in the communication the n number of symbols. So we are always interested into the average. We have to take the average value of this, and that average information itself is called entropy. So entropy is called nothing, it is just a parameter of randomness, uncertainty. It is represent the average number of bits per symbol. How many bits in the average form, how many bits are basically assigned to the each symbol, right, in the average manner, that will basically represented by the entropy. Unit is always what we have discussed, This is called how many bits we are going to assign for the each symbol. So how many bits we are assigning to the each symbol is called nothing, it is just a what? Bits per sample. So bits per symbol, right? Okay, bits per symbol. And average information itself is called entropy. How we are going to do it? Everyone try to understand. एक छोटे से एग्जाम्पल से समझाता हूं. Everyone, suppose I am writing x1 is there and x2 is there. Suppose I am writing कि probability of px1 is called 1 by 2. Probability of px2 is also called 1 by 2. So information associated with this x1 is called nothing, it is just a 1 bit, because log 2 base of 1 upon px1, and information associated with this x2 symbol is called log 2 base of 1 upon px2. Now if you want to find out, here we can say that 1 bit information, here we can say that 1 bit information. But look at here, this is called ixn, this is called ix2. Now if you want to find out information or entropy, entropy is called average information. How we are going to find out the average? Sir, px1 is multiplied with the ixn plus px2 is multiplied with the ix2. This is called average. This one is called average information. Probability is multiplied with the individual value. Now occurrence of that value will give you what? The average. So here if you want to find out, this is called normally I am writing. Suppose this is for the 2 it is happening. But suppose the n number of symbols are there. Suppose n number of symbols are there, then we can say that I h of x equal to px1 I x1 px2 I x2, and suppose n number of symbols are there, we can write for the all symbol. So this information or entropy we can write for all value of I pxi ixi, and we already know that what should be the value of ixi, log 2 base of 1 upon जूही. तो के न्यू बैच कब से स्टार्ट होगा सर? जूही ऑलरेडी 2023 का बैच स्टार्ट हो चुका है, एंड यू कैन फील ऑलरेडी डिजिटल इलेक्ट्रॉनिक्स इज अबाउट टू फिनिश्ड एंड कंट्रोल सिस्टम इज गोइंग टू स्टार्ट फ्रॉम द 25th. सो अराउंड 20th के आसपास नया बैच स्टार्ट होगा जूही, राइट? सो वी कैन से दैट एवरीवन for all value of I, we can also write p of xi log 2 base of 1 upon p of xi. This one is called nothing, it is just a entropy. This is called nothing, it is just a entropy, right? Okay, this is called entropy, right? Okay, now everyone, there will be the entropy if you know, then there will be the one thing more guys, information rate or bit rate. Whenever I am writing the bit rate means what? Bits per second. So we required bit rate RB, that is called bits per second. Bits per second. We required our bits per second. Now we already know that. Entropy we know that. What should be the entropy? Entropy is called bits per sample. So we know that bits per sample. And now we required bits per second. So what is basically required here? So here the sample is required, and in the denominator second is required. So sample cancel out, and second you will get bits per second only. So this is called R, this is called H actually, and this one is called sample per second itself is called nothing, it is just a whatever the per second, that is called rate. So it is sample per second, sample rate, message per second, message rate, bit per second, bit rate, right? Sample or anything you can write, right? Symbol per second, symbol rate, like that. So sample per second, we can say that sample rate or symbol rate, sample rate, and sample rate I am representing as R. R is called symbol rate or sample rate, or symbol rate we can say that. Number of samples per second. You can also understand like this. H will represent how many, suppose we have two sample, this one is sample and this one is sample. How many each sample having the number of bits, na, that is represented by the H. So H is saying 2 bits per sample. This one also 2 bits, this one also 2 bits. This one also assigned to the 2 bits, this one also assigned to the 2 bits. This is given by H. But in the 1 second, how many bits sample we are transmitting? Suppose in the 1 second 2 sample we are transmitting, and each sample encoded by the 2 bits. So how many bits we are transmitted? So 4 bits we have transmitted. That's why how many sample transmitting in 1 second and how many bits is assigned to the each sample. That's what the multiplication will give you the bit rate, right? Okay. Now in the entropy function, if you want to discuss, guys, always you have to remember, suppose I'm saying this is called transmitter and this is called nothing, it is just a receiver. I'm writing the receiver as a Y and I'm writing the transmitter as a called nothing, it is just a X. So there are X1, X2, X3. Suppose I'm writing Xn symbols are there. And in the receiver side, we are receiving Y1, Y2, Y3. Suppose Ym symbols are there. Now, the entropy, so there are the few things are basically there, guys. One is called, everyone, one is called mutual probability. Mutual entropy, we can say that. Mutual entropy means entropy of the transmitter and entropy of the receiver. That is called mutual entropy. So if you want to find out the mutual entropy of transmitter, that is called X. So we can say that X1, X2 all are basically given for value of I equal to 1 to N P of Xi log 2 base of 1 upon P of Xi. This is called mutual entropy of transmitter. Mutual entropy of transmitter. This will give you the idea how many sample we are, or how many bits we are or how many bits are average assigned to this particular. How many bits are basically assigned to this particular symbol. That's what basically given. Right, okay. Now if you want to find out in the output, how many bits, average number of bits is basically received at the output for the Y. That is given by H of Y. This is called summation of I equal to 1 to M P of Yj, J लिख देता हूँ, और log 2 base of 1 upon P of Yj. It's a very simple chapter, right? It's a very, very simple chapter. Right, we know that this one. Now, third one is called conditional. Suppose if you want to find out the H of or joint entropy, this is called joint entropy. Joint entropy is called nothing, it is just everyone. Joint entropy is called summation of I equal to 1 to M. M था, N था, N था. अरे I equal to 1 to N, J equal to 1 to M. Joint probability is basically required for this. Yj log 2 base of 1 upon P of Xi Yj. And with the example, it will give you the more clarity on it, right? Okay. This is called joint entropy. Now, if you want to find out the conditional entropy, this is called conditional entropy. Now, if you want to discuss about the conditional entropy, how we can say that? Hy by x, then we can say that for I equal to 1 to N, for J equal to 1 to M, P of Xi Yj log 2 base of 1 upon what should be the Y by X now? So here also Yj upon Xi. This is called conditional entropy. And suppose if you want to find out X by Y, then also summation of I equal to 1 to N, J equal to 1 to M, P of Xi Yj log 2 base of 1 upon P of Xi by Yj. This one is called conditional. Now people are saying, sir, I am not understanding what should be the meaning of this. So everyone try to understand. By the Venn diagram, let me explain you, right? Okay, now everyone try to understand. This entire green one is called nothing, it is just a h of x. This entire red one is called nothing, it is just a h of y, entire. And if you want to discuss about h of x comma y, this one is called h of x comma y. Right? This part we have to take only once. Okay, now. Sir, what should be the meaning of this part? This one. इसको ऐसे समझ लीजिए, highlighter. Okay. If you want to discuss about this one, guys, this one is called nothing, it is just a h. This is called x for known value of y. This is called h of x by y, right? Okay. Now if you want to discuss about this one, suppose if you want to find out this value now, we can say that this is called h of y for known value of x. This is called like this. And now if you want to discuss about the middle, this one, if you want to discuss about this part is called nothing, it is just everyone, I of x comma y. So now with the help of this, anything you are able to find out. How? Look at here. If you want to find out the I, x comma y, how we are going to write it? This is called h of x minus h of x by y. In the entire part, if you subtract this one, you will get this one only. And now if you want to write from here also, you are going to get it. Sir, h of y minus h of y by x. This will give you nothing, it is just this part. This is called nothing, mutual information. And this mutual information is very important, guys. We are going to find out with the help of this information, we are going to find out the channel capacity. Right? Always I will discuss about the channel capacity with the help of this only. Right? In the every type of the channel, right? Ki channel capacity, if you want to discuss, this is called I, x comma y, maximum into RS, symbol rate. This is called channel capacity formula. Everywhere we have to use this formula to find out the channel capacity, guys. Hope everyone, this point up to this portion, everything is clear, right? How we are going to solve it? So due to the less, we'll solve the remaining part into the next class, but just take this one as a homework question, guys. A binary channel is described by the following diagram. This is the binary symbol is given, and you have to find out the h of a, h of b, h of a comma b, h of a by b, h of b by a, I a comma b. This one also. You have to solve it and you have to write into the comment box of this particular video. Comment box of this particular video. So everyone, thank you very much, all the very best. See you into the next class, that is the tomorrow. Not tomorrow, I will let you know, but you have to ensure that all of you are going to join that particular session, because in the digital communication, why I have skipped the M-array signaling, because if the more people will take, because that is lots of people in the India, you can see that every people are basically confused to solving the question of the M-array signaling. So M-array signaling a random process, I will take it in very smooth manner, in very much of detail, but only when the more people are basically take the interest towards this GATE preparation, right? So thank you guys. Thank you very much. All the very best. Take care everyone. Bye bye. Thank you. Thank you. No password, Rakesh. Directly you will get, no issues.